So in the last session, we were talking about modeling of foundation. So we have seen multiple steps. Like first we have talked with the design of drawing of grid lines and then defining the material properties and rest of the things. So we are at assigning the loads. So actually we have assigned the loads for one type of columns. So we have discussed that we have two types of columns here. So one is C1 type and the other one is C2 type. So we have assigned the loads on C1 type of columns. Now we need to assign the loads for C2 type of columns. So let us do that. So let me go to the CSICF software. So how to open the existing model, file, and then open, and then select the model whichever you have created. So this is my model, which ends with .fdb, and then select that. So this is the model that we have made it. So now we have to assign the loads for C2 type of columns. So let us assign the loads for C2 type of columns. So before assigning the loads for C2 type of columns, first we have to select the C2 type of columns. So how to select that? So just go to select, and then properties. And in the properties, we are going to select the column properties. So just click on column properties and then select the column 2, whichever we have to assign the loads. So in the previous session, we have assigned the loads for 230 by 600 column. Now we need to assign the loads for 450 by 450 column. So just select that and then click OK. So now all these things have got selected. You can see at the bottom, 16 lines have been selected. So there are total 16 columns of C2 type. Okay, C2 type columns are 16. So now what we have to do is we have to assign the load for all these 16 columns. Okay, we have to assign the load for all these 16 columns. So how to assign the load? So in order to assign the load, we will use an option called assign. So before using the option of assign, first we need to see whether the columns are really selected or not. So how to see that? Just right click anywhere on the screen and then you can see an option called show selected objects only. So just click on show selected objects and you can see all these are the columns, 16 columns that are selected. Now what we have to do is we have to select the points, right? We have to select the points. So we were discussing that for every column we have 2 points, one at the top and another at the bottom. So when we are assigning the loads, either you assign the loads at the top or you assign the loads at the bottom. So don't assign the loads both at top and bottom. Okay. So what we have followed is we were following assigning the loads at the top point only. So let us assign the loads at the top point. So how to select only the top points of all the 16 columns? So for that, we need to go to 3D view. So just click on 3D view and here you can see the points. And again, here also it is showing the datum point. So in order to see only the top level, okay, in order to see only the datum level, anybody remembers how to go with how to see the only the datum level? Can anybody tell how to see only the datum level? Anybody remember that? Okay, fine. So for that, what we have to do is we have to go to edit, okay, edit and then grid data, and then you can see an option called add or modify grids. Okay, add or modify grids. So just click on add or modify grids, and then you can see this option called modify or show system. Click on that, and here make sure to give zeros to all. Even though sometimes when you give 0, it shows in this way only. So just make sure that one, and then click OK. So once you click OK, you can see only the bottom layer, right? So now we have to select the points, the top points of the column. So for every column, as I was mentioning, we have to select only the top points. So how to select only the top points? So in order to select only the top points, just click on them. That's it. Nothing much we have to do. So go here and then I'll come from here. So you can see there is a point here. So just click on that. And then here is the point. Click on that. So make sure to come one line by one line. I mean, complete one grid line first and then go to the second grid line instead of coming randomly. So this one, and then here. So make sure to select all the 16 columns grid points. I mean the top point for a column. So I am selecting all the points. Right. So we have selected all the 16 points. Can you see at the bottom? All the 16 points have been selected. Right. So now what we have to do, we have to assign the loads. So how to assign the loads? In order to assign the loads, we have an option which is called as assign. Okay, we have an option which is called as an assign. So just click on assign at the top menu bar and then go to load data. In the load data, we are going to apply the point load. Click on that. And then here it is a live load, not a dead load. So select, change it to live load. And then what is the load on column 2? Okay, let us see that. So the load on column 2 is 1020 kilonewtons. Okay, the load on column 2 is 1020 kilonewtons. So let us give the Z value as 1020. Okay, 1020. And then moment along all the directions will be 0. We don't need to do that because it will calculate on its own. And then the size of load for punching shear. What does it mean? It means the dimension of column 2. What is the dimension of column 2? 450 by 450 mm. So this is the dimension of column 2, 450 by 450 mm. So let us give the x dimension as a 450 and y dimension also as 450 mm. So once you give this one, so make sure to go with replace existing loads. Okay, just make sure replace with existing loads. So click OK, and you can see the loads have been applied. You can see the 1500 kilonewtons of load, sorry, 1020 kilonewtons of load that is applied on each column. If you want, you can rotate and check also. Right? Can you see in a much better way? You can see here. So like that, you can assign the loads. So with this, what we have completed the assigning of loads on both the first column, that is column 1, and column 2 also. So let us do that. So we have done that one. So let us see the loads for remaining columns also. Now we are seeing the loads only for column 2. So how to see the loads for column 1 also? Just right click and then click on show all objects. Okay, click on show all objects. Now you can see all the footings are being visible. Loads will not be visible. Whatever the recent one, only those things will be visible. Right. So now what we will do is let us do the analysis part. So before doing the analysis part, let me explain you a couple of options that we need to know in order to do the analysis. So first, let us go to the XY plane. So click on XY and you can see all the points have been, all the columns along with the footings are there. Right. So now there is one option which is at the bottom that's called as set display options. You can see here this one, this tick mark you can see here, set display options. This one is called as set display options. What is the importance of this? So let me click here, click on set display options and you can see a dialog box that is popping up. And here, if you observe, there are multiple options that are available here. So if you click labels, what will happen is once you check labels and then once you click OK, all the labels for columns and footings will be displayed. So let me select that. So I have selected labels, click OK. And can you see the labels that is coming down? For each and every footing and column, there are labels that are being given. So like that, labels will be given. Okay, like that, labels will be given. How to do that? So in the quick access bar, set display options. And then if you uncheck this one, and then if you click OK, then labels will not be displayed. Right. So let us explore other options as well. So click on the tick mark in the quick access bar that's called as set display options. And here you can see a couple of other options, which is called as view by colors. Okay, you can see an option called view by colors. Okay, so how you want to see? Do you want to see the colors of objects or based on the section properties, based on the material properties, based on the groups? So we have given the section properties for one color, materials also we have changed the color, for groups also we have changed the color while doing the modeling part in the beginning stages. So let us verify that. So here, let's change the color of objects. Okay, let me select the objects. So let me go with this one, that is view by colors of objects. Okay, view by colors of objects and then click OK. Let me click OK. Right. So now what we will do is let us change the colors of objects such as beams, objects in the sense beams, columns, slabs. These are called as objects. So how to change the colors of object? For that, there is an option called options. Okay, there is this option called options. And then you can see an option called graphic colors. Okay, there is this option called graphic colors. Click on that. And here you can see the colors. Okay, for points there are some colors. For diaphragm wall there is colors. So diagram wall, diagram fill positive, diagram fill negative, diagram fill range. So likewise there are multiple colors that are available, and you can change whichever color you want. Suppose let's say I want to change the floor fill. Okay, I want to change the floor fill. Let us try with couple of options. So how to change the color? Just click on this color. Okay, whatever color that you see, just click on that and you will get the multiple colors. And select any any random color. Let me select some thick color, which is blue one. So select the blue color, click OK, and then click on OK. Now, once you click OK, what will happen is you will see all the objects in blue color. Can you see? So all the objects are available in the blue color. So like that, you can change the color of any options or any elements or any objects you can see. Now let's say that I want to reset the colors. Okay, I don't want to see in this way. I want to see the default colors which is provided by safe software. So how to provide that? So for that, again, there is this options and then go to graphic colors. In the graphic colors, there is this option called reset all defaults. Can you see at the bottom? Reset all defaults. Just click on that. So click on reset all defaults and then click OK. Right. Can you see the default colors have been visible now? So like that, we can change the colors of any elements and we can go back to the default options also. Okay. Right. How to do with that? Go to options. Okay. Graphic colors. In the graphic colors, you can change whatever you want. Okay. Options, graphic colors, and then click on reset all defaults or change the colors whichever you want, and that's done. Right. So now what we will understand is we will see a couple of things with respect to the loading. Okay. So just go to 3D view. In the 3D view, I am seeing some loadings. Okay. Loading of 1020 kilonewtons of loading I am seeing. Now let's say I don't want to see the loading. Okay. I don't want to see the loading. So how not to see the loading part? Okay. So for that, there is this option which is called as show undeformed shape. You can see here a circle shape you are seeing here. Okay, this one. So this option is called as show undeformed shape. Let me keep the cursor there so that you will understand. Right. Can you see here? Show undeformed shape. So once you click on show undeformed shape, what will happen is it will not show any kind of loading. Okay, it will not show any kind of loading. Let me click on this one. Now, can you see? Are there any loadings that are available? No. This does not mean that loading is removed permanently. We are not just seeing the loading. Loading is actually applied, but we are not seeing that. That's the difference. So don't think that once you click on show undeformed shape, loads will not be there. Loads will not be completely removed. Loads will not be visible. That's it. That's the difference. Right. So now what we will do is let us do some work with view by colors of couple of other options. Let me go to the XY plane. Okay, let me go to the XY plane and then click on set display options. Okay, click on that and then view by colors of, first we have tried with objects. Now let us try with the section properties. Okay, click on section properties and then click OK. Right. Now, can you see all the column ones are showing in one type and column two is showing in another type. So that means all footing ones or F1 type of footings are being shown in one color. F2 type of footings are being shown in another color. That's the difference between view by colors of section properties. So how to see that? Click on set display option, section properties, click OK. Automatically it will define, because we have defined the section properties based upon the footing size and based upon the column size. So based on that, it will software will automatically decide what are the different types of materials or what are the different types of objects or section properties are available. Right. So now let's go it in little deeper way. Let's go to define. In the define, I want to see the slab properties only. So just click on slab properties and select any one type of slab. Let me go with the first one first. F1 500 underscore M20. Click on that and then click on modify or show property. Okay, I want to change the color. Now you can see the color of F1. Okay, let me here. Can you see the color of F1 type of footings? They are all in the red color. Okay, why they are in the red color? Because here we have selected in the display, we have selected red color so that similar color is being shown. It's not typical red color, but it's almost red color. Okay, right. So now you want to change the color of this one. Okay, you want to change the color of this one. So how to change? So let us go with this. So click on the color. Okay, let me click on something like black and then click OK and then click OK. Okay, OK. What happened? Why the change is not applicable? Let me do one more time. So define slab properties. Let me select footing one and then modify or show property and then let me change the color. So here I'm changing it as black. Let me go to 3D view and then check, because sometimes in 2D view it will not be visible. Yeah, can you see? In 3D view it is visible. So in 2D it is not clearly showing. Yeah, now it is showing. Okay, it is being refreshed and it is showing. So like that, you can change the colors of any type of structural element. Okay, any type of structural element. Right. So let's see the same thing for columns also. Okay, let us see the same thing for columns as well. So how to go with that? Just go to define. In the define, so we have to go with column properties. So click on column properties, select any column whichever you want, and then go to modify or show property. Click on modify or show property and then change the color whichever you want. Let's say I want to see all these things in the red color or something like green color. Okay, so select this one and then click OK and click OK. Okay. So now let me go to 3D view. Right. Now can you see all the columns are visible in the red color? I mean all the C1 type of columns in the green color, C2 type of columns in the black color. Can you see all these are in the black color? These are basically C2 type. And these are visible in the green color. Basically these are C1 type of columns. So like that, you can change the colors of any element by making yourself into set display options and also the define things. Okay, you can change the color of slabs, beams, any element, whatever you want, you can change anything. Right. So let me click on set display options. Right. So in the set display options, now what we will do is let's look at the model based properties. Okay, let us look at the model based property. What does it mean? It means you can see the material properties. Okay, the material properties. Let us select the material properties and let's see what will be the change. So check the material properties. Once you check the material properties, so click OK. So here, why we need to work with this one? I mean, where it is important, material properties. So here in our in this particular simple modeling part, we have only one grade of concrete. M20 grade of concrete is there, and we have only one grade of steel, Fe500 grade of steel. Now, suppose let's say there are some structures or there will be some structures where we will use different grades of concrete based upon the loading phenomena. Suppose let's say there are some columns which should be very strong columns. Now for those columns, we might increase the grade of concrete to M40 or M50 grade of concrete. There will be some columns which are not so important, so we will use the typical M20 grade of concrete. Now you want to identify which columns have M20 grade of concrete and which columns have M50 grade of concrete. And for higher strength concrete, higher strength columns, obviously we will use higher grade of steel also. So higher grade of steel is nothing but Fe500, Fe550D, Fe550D, DXX. So like that, we have different grades of steel. So if you want to differentiate the structural elements based upon the materials, such as grade of concrete, grade of steel, we are going to use this option called material properties. Okay, that is where this option will be useful. So just select this one and then click OK. Right. Now here you can see all these things are visible in the same color. Okay, right. So let us change that. So let us go with define. In the define, I want to change the material properties. So materials and then select. This is what we have select. We have given Fe500 and then M20. So let us go with concrete first. So select M20 and then modify or show material. Click on that and here you can change. Okay, here you can change. So now you can see all these foundation slabs are visible in the green color. Why they are visible in the green color? Because M20 grade of concrete, we have given the green color here. You can see material display color, we have given it as green. So now let's say I want to change this color. So how to change? So click on that and then give any particular color. Let's say I want to give something like ash color. Okay, something like that. You can change the contrast of the color as well. That's completely up to you. So click OK and then click OK. OK. So it will not be displayed. Just go click on XY and then come to 3D. Now you can see. Even in XY also, you can see the change in color. So like that, we can modify the colors. Okay, like that, we can modify the colors of anything. Right. So now in the present model, we have only two types of footings. One is F1 and the other one is F2. But in real-time constructions, we may have more than 50 footings, more than 100 footings. And now what we will do is, let's assume 15 types of footings are there in those 100 footings. Okay, what I mean is, so let us say there are total 100 footings are there. Okay, total footings are 100. In these 100 footings, there are 15 different types of footings, or 10 or 5, some number I'm telling. So let us say that there are some 15 different types of footings. Now, for all these 15 different types of footings, we have each dimension. So let us say footing 1 is having some dimension, footing 2 is having some dimension. So likewise, footing 1 will be having one type of concrete, footing 2 will have one type of concrete, let's say M30 grade of concrete, and footing 1 will have different grades of steel, let's say it as Fe415, and footing 2 will have other type of steel, which is Fe500. So likewise, when you have different categories, okay, these are basically groups. So F1 is one group, F2 is one group, F3 is one group, F4 is one group. So likewise, we have different groups. So if you want to see the properties based upon the groups, okay, if you want to see the properties based upon the groups, so for that we will use define. Okay, just go to define and then you can see an option called groups. Okay, there is this option called groups. Click on groups and here you can see display color as red color, and here you can see all groups. Okay, all groups. So now in our present model, we have only two types of footings, which means how many groups are there? Only two groups are there. So what we will do is, let's create two groups. So currently we don't have any groups. We have to create groups. So let us create two groups here. One thing which you have to remember is, by default, one group will be available and that group name is all. Okay, whatever the group that you are seeing here, that is the default group. Okay, that is a default group. So now what we will do is, let us write two groups. One is F1 group and the other one is F2 group. So just come to the next line and then double click there and then type F1. That's it. Just the type, that's it. Nothing much you can do. And here, just click somewhere aside so that second group you can type. Okay, now what does it mean is group type. Okay, here group name is all, that's a default one, and the second one is F1. So what does it mean? F1 under all. Okay, well, under all category F1 is there, right? So now if you want to change the color, okay, for F1 type of footings you want to see a different color. So let us change the color. So click on change. That is come. What is happening? Let me click here. I think it's not getting changed. So it should get changed, but let it be like this. Okay. So now let us give the second type of footing also, F2. So let me give the second name as F2. Right. So for F2 also we have given. So here what we have done, we have created the groups. So for F1, let's say you want to change the color. So click on that. You can see automatically it got selected as yellow color. And for F2 also it should get yellow. So you can see, so click on that, select any color. So let's say I'll go with some pink color. Right. So now what we have done, we have created two groups. One is called F1 and the second one is called as F2. Right. So now just click on OK. Okay, click on OK. Now go to select. In the select, go to properties, select properties. And in the properties, what we have to do is, we have to go with the slab properties. Footing 1, footing 2 are basically slabs. So go to slab properties and here you select any one. Okay, so now let me select F1. Okay, so here what will happen, click on that. Okay, click on that. So now what it will happen is, now all slabs of F1 underscore 500 underscore M20 will get selected. Okay, so how to go with this one? So go to select. Okay, go to select, and then properties. Okay, and then slab properties. Like that we have to go. Similarly, column properties also we have to select. So let me go with slab properties first. Select slab properties. Let me select F1, click OK. Right. Similarly, you can see at the bottom, 8 areas have been selected. Okay, 8 areas of which group? F1 group have been selected. Right. So similarly, columns also. If you want to select all the columns, so how to select all the columns? So in order to select all the columns, again go to select. Okay, select properties, and here column properties. So click on column properties, select any column. I'll go with the first one, 230 by 600, and click OK. Now can you see 8 lines, 8 areas, 32 edges have been selected. Okay, so that's how you can select based upon the material properties. Okay, based upon these are just options, that's it, nothing much we can work here. Right. So now what we will do is, the next part is we need to work with the loading part. So technically we can run the analysis now. So here, before running the analysis, these are just some options. We'll work with couple of other options also as we progress with time. Okay, right. So now what we will do is, there is another step for assignment of loading. So here I told that assigning the load, you can consider this as 7.1. Similarly, we have the other type, which is 7.2 also, which will be almost similar, but there will be one small change. So here, what I'll do is, I'll just tell you the change, but when we are doing a real-time project, then we'll understand how the change will be implicated. Now, for that, what we'll have to understand is, we have to understand the subgrade modulus. So in order to understand this second part of the loadings, we need to understand the subgrade modulus. What is that? So the other thing that we have to consider in our model is SPC of soil. So till now we have assigned the loads, which are basically the live loads. Okay. Now we haven't worried about the SBC of soil. So soil pressure, we have upward soil pressure, we have not talked about that. But we have to apply that upward soil pressure also. Okay, in our criteria or in our design or in our modeling part, we have to apply the upward soil pressure also. So let me explain you this one. So once we have the SBC of soil, okay, once we have the SBC of soil, so in our case, what is the SBC of soil? Let me check that. So SBC of soil is 300 kilonewtons per square meter. So we have the SBC of soil as 300 kilonewtons per square meter, right? So now this SBC of soil, or once we have the SBC of soil, accordingly, we can find the subgrade modulus. Okay, we can find the subgrade modulus. So the formula for subgrade modulus is K equals to, okay, subgrade modulus is defined with K. Subgrade modulus K equals to SBC of soil, okay, SBC of soil upon the allowable settlement. Okay, SBC of soil upon allowable settlement. So I'll just write in shortcuts, allowable settlement. So this units will be in terms of, so SBC of soil by allowable settlement will be in terms of kilonewtons per square meter. This is subgrade model. This value is very much important when we are doing the real-time designing of columns or with real-time designing of footing. So from next session onwards, what we will do is we will design a square footing, rectangular footing, sloped footing or trapezoidal footing. All these things we are going to do. So when we are designing these ones, we will come across this point called K, that is called a subgrade modulus. Right. So the formula for subgrade modulus is SBC of soil by allowable settlement. Now let's consider SBC of soil is 300, which is provided, and allowable settlement. Usually, what will be the allowable settlement in columns? I mean in the footings. So it should be in between 25 to 50 mm. This is the allowable settlement. Maximum to maximum, we can go up to 50 mm of settlement, and approximately we'll get somewhere around 25 mm, 2.5 centimeters to 5 centimeters. but we will never consider this 50 as the extreme point. We'll always design for the lowest possible settlement, which is for 25 Okay, we should never design the footings for 50 settlements. We should always design for the lowest possible settlement. Now here we have to define three types of soil subgrade properties. Okay, we have to define three types of soil subgrade properties. What are they? So the first one, let me delete all these ones. The first one is called as, let me write that. We have to define, or let me write this one first, subgrade modulus. Write in small letter. So subgrade modulus K equals to, so SBC of soil, SBC of soil upon allowable settlement. Allowable settlement. So the allowable settlement in any type of footing should range between, allowable settlement equals to 25 to 50 This is the allowable settlement, right? So here we have to define three types of soil subgrade properties. What are they? Let us understand that. So three types of soil subgrade properties. So what are the three types of soil subgrade properties? So the first one is called as area contact with soil. Okay, the first one is called as area contact with soil mass. Okay, area contact with soil mass. So this is called as soil subgrade property. Okay, soil subgrade property. This is the first one. Soil subgrade property is nothing but area that is contact with the soil mass. And the second one is called as line contact with soil mass. The line contact with soil mass. So this is called as line spring properties or property, line spring property. And the third one is called as point contact with soil mass. This is called as point spring property. Let me show you where these options will be visible. So point spring property, right? So these are the three different properties. Let me go to the safe software, and to see that, just go to define. In the define, we can see an option called soil subgrade properties. So click on soil subgrade properties, and here we have to define this properties. So just click on add new property, and then you can give the name to the property. Let's say I'll give the name as SBC 300 at the rate 25 settlement. Okay, the SBC of soil is 300 kilonewtons per square meters. That is what I have given. And the allowable settlement is 25 You can give any name, that's up to you, right? So the property name I have given. Okay, so property name. And then you can see this option called subgrade modulus. Okay, subgrade modulus. So here we have to give the subgrade modulus. So how to calculate this subgrade modulus? So the formula for subgrade modulus K equals to, we have written that K equals to SBC of soil divided by allowable settlement. Okay, SBC of soil upon allowable settlement. What is SBC of soil? 300, and allowable settlement is 25 So 300 by 25. You can directly calculate here. 300 divided by 25. Just click enter. You can see the allowable settlement is, sorry, 300 is in kilonewtons. So let me keep it in terms of kilonewtons per square meter. So let me keep the 25 also in meters. So 0.025, right? Click enter, and you can see the subgrade value or subgrade modulus is 12,000 kilonewtons per cubic meter. This value is very much important when we are doing the analysis, especially the one-way shear and two-way shear analysis. We'll see that in the next sessions. And here you can see an option called non-linear options. What does it mean? Non-linear options is nothing but, you can see there are four options that are visible. The first one is called as none. Basically, it's a linear. Second is tension. Third is compression, and fourth one is elastoplastic, which is useful now. So usually we'll go with compression only. Why? The reason is, whenever we design the columns along with the footings, all the columns will be in compressive forces, or they will be experiencing the compressive forces. They will never experience the tensile forces. Okay, they'll never experience the tensile forces. That compressive force can be from the top to bottom or from bottom to top. This is because of the soil subgrade pressure or upward soil pressure. Whatever the pressure that you see at the bottom, it is all because of the soil pressure. And whatever the thing that you see from the top, this is all basically the load, either dead load or live loads. So that's why we always select compression only. Now, when you go with tension only, what does tension only represent? Suppose when you are designing a slab, let's say you are designing some slabs. So especially when you are designing slabs, at some points, slabs will experience the tensile forces also. Suppose let's say in the corners, we always provide, for two-way slabs, we always provide the torsion reinforcement. Why we provide torsion reinforcement in the columns? To avoid the torsion reinforcement in the slabs to avoid the uplifting of the slabs. Suppose when my load exactly falls at the center of the slab, what will happen? There is a chance that all these four corners will get uplifted. So to make a proper bond between the corners of the slab with the respective beams and columns, okay, with the respective beams and columns, what we do is we are going to provide the torsion reinforcement. And when you provide the torsion reinforcement, the corners will be held properly and such that there will not be any kind of upliftment. But let us assume that uplift is there. So when there is uplift, obviously the tensile forces will be acting there. Okay, obviously the tensile forces will be acting there. Elastoplastic is a scenario where we see in pre-tensioned structural members or pre-stressed concrete structural members. Okay, this is a completely different scenario. Elastoplastic scenario is completely different. That we'll not talk about. And then last one is linear. Linear is nothing but you can see none also as an option. So linear is nothing but there is no compressive forces and there is no tensile forces. So when there is no compressive or tensile forces, then you can select linear. But in any structure, we don't have this kind of phenomena. So we'll have either compressive forces or tensile forces or both also. So mostly since we are focusing on design of foundations, all the foundations are subjected to the compressive forces, either the positive compressive force or the negative compressive force, but they will be mostly subjected to compressive forces only. They will never be subjected to tensile forces. Even if they subject to tensile forces, that will be negligible amount only. So we don't need to consider that because compressive forces will be the dominating ones. So that's the reason why we select a compression only. Okay, why we select compression only, right? So here property name I have given, subgrade modulus I have given, and here compression only I have selected. Okay, it is because the soil will be under compression because of the load application, and then click OK. Now you can see the SBC 300 at the rate 25 mm is being given. So if you want to delete this one, soil one, so select that one, click on delete property, it will get deleted. And then click OK. Right. So this subgrade modulus, what is the subgrade modulus value? 12,000. Okay, that is SBC of soil by allowable settlement. It is coming as 12,000. So this subgrade modulus, which is 12,000, is assigned to where it has assigned to. It has assigned to all the foundations. Whatever the foundations that are available, it has been assigned to all the foundations. Okay, remember that. So the subgrade modulus is something which is assigned to all the foundations as it is the one that is in contact with the soil. It is the foundation, not the column that is in contact with the soil. Column will be in contact with the foundation. Foundation will be in contact with the soil. So the soil will be there. So when you are applying the subgrade modulus, the value of K has to be applied to the foundation, not to the column. Okay, not to the column. Why it is applied only to the foundation? Because ultimately this slab, the foundation slab, is the one which is in contact with the soil. Okay, that is the one which is in contact with the soil. Right. So now let us select that. So let me delete this one. Right. So go to select. In the select, go to select again. Go to properties. In the properties, we have to go with slab property. So slab is nothing but foundation only. So click on slab properties and here select both the ones. Okay, just hold control. So if you just press one and then if you press the second, it will not be selected. Once you press the first one, hold control and then press select the second one also. Okay, and then click OK. Right. So this is done. Now what we have to do is we have to assign the supports. So let us see that. What is that? Go to assign, and then you can see an option called support data. Okay, support data. Go to soil properties, and here select this one. So this is our soil property. So select this one and then click OK. Right. Can you see the subgrade modulus has been applied to all the foundations? Can you see here? SBC 300 at the rate 25 for all the foundations, it is being shown. That means the subgrade modulus, the value of K is applied to all the foundations. Okay, the subgrade modulus is assigned to all the foundations or footings, you can say. So this is all about the modeling part. Okay, this is all about the modeling part. So the next part is about the analysis part. Okay, the next part is about the analysis part. So what are the different steps that are available in the modeling? So these are the 7 different steps, or you can say 8 different steps that are available in the modeling. So mostly we'll follow this scenario also, but based upon the type of footings or type of foundations, we'll have some other additional steps will also come. So I'll explain them once we talk about that type of footing. So this is all about modeling part. Now the next thing is analysis part. So how to do the analysis? Now here you can see there is a symbol which is a play symbol here. Can you see here a kind of play button? Okay, just in STAD and ETABS also we'll see the same symbol. So once you click this one, it will be asking you to save the model. Okay, let me click on that. So click on run analysis and design. So since the model has been selected, you can see at the bottom. So the modeling has been done. Okay, the modeling has been done. I mean, sorry, the analysis has been done. Now you want to see the results of the analysis. Okay, you want to see the results of the analysis. So how to see the results of the analysis? So in order to see the results of the analysis, just go to display, and then you can select whichever option. Suppose if you want to see the design of the slab, just click on that. If you want to see the shear forces and bending moments, you can click on this. So like that, whatever things that you want to see, you can click here. But here we don't see the results. The reason is we have not designed it perfectly. So randomly I have taken some dimensions here and then I have assigned. So we have not completely done the modeling part and completely made the analysis part. And even if I show you the results, we don't know whether they are the right results or wrong results. So for that, in the next session, what we will do is I'll tell you how to design or how to model and design the isolated rectangular footing or square footing. Maybe let's go with square footing only. So in the next session, we will see modeling and analysis of square footing. We'll see this one. So we will first do the modeling part. And once we do the modeling part, we will check the analysis part. Once we do the analysis part, we already have the manual calculations for all these ones. So suppose let's say square footing, we have the manual calculations for all the square footings. So I have shared this document with you also. We will cross verify with this document as well. Okay, we will cross verify whether the length, width, everything are coming approximately. They will not be coming exactly same, more or less same will be coming, but we'll check, we'll have a cross check. That's called as validation. And once we complete the manual validation with the software validation, I also have some Excel sheets as well. I'll share you those Excel sheets also. So here you can see there are a couple of Excel sheets for combined footing design, strap beam footing design, and then the pile cap design. Pile cap design, I'll just give this Excel sheet because we'll not be focusing on pile caps. And then one-way shear check design. So like that, I have multiple Excel sheets which were prepared. So I'll share you these ones also. Okay, once we complete that one. Right. So that's all about from my side for this particular session. In the next session, we'll be working on the modeling and analysis of square footing, isolated square footing. Okay, right. So that's from my end. If you have any doubts, you can unmute and ask the doubts. Thank you.